exercise is construct one of our perpendicular bisectors that we made yesterday. So this part should be just review, easy peasy. Okay, so to make a perpendicular bisector, you're going to put your compass point on one of your end points. Okay, you're going to set the radius of the compass to a little bit more than halfway-ish. So between halfway and the whole length. Okay, and then we're going to draw some arcs. So I'm making this arc. Oops. Oh, did I just mess that up? Oh, shoot. Hold on, guys. I just hit the wrong part of the pencil. This arc around P, and without changing the setting on the compass, keeping the same radius on the compass, I'm moving my metal tip over to Q and making that arc over there as well. You don't have to do the entire circles. If you want to do this entire circles, that's fine. You just might not always have room. Okay, so where these 2 points, arcs intersect are on 2 points that are equidistant from P and Q. Okay? These 2 points define our perpendicular bisector. Obviously, we didn't exactly, all of us pick the exact same radius for these arcs. There are infinitely many points that we could have picked. Infinitely many pairs of points that we could have picked. I kind of want them to be red. Okay. Okay, we are going to label the point of intersection for P and its perpendicular bisector point M. Anybody have any ideas why we're calling it M? Yeah, M for midpoint. Okay, we show that it's perpendicular with one of these little 90-degree angle marks. One of the cool things about, did we do linear pairs yet? Did we do linear pairs of angles? No, that'll be later in this unit. Okay, don't worry about it. What properties does our perpendicular bisector have? So there are a couple of things. One is pretty obvious. What does perpendicular mean? What angle does it intersect our segment at?
90 degrees.
Yes. Makes a 90-degree angle with our segment, which is PQ. Okay, what else? What did we say that bisect means? What does bi mean? Two. Sect is like chop, right? Cut. So it cuts PQ into how many congruent pieces? Okay. Okay, so we know that PM is congruent to PQ. When I make those little ticks like that, it means that those segments are congruent to each other. So I can say that PM, the segment, is congruent to MQ, the segment. Okay, so those two are probably the easiest ones. The next one I want to talk to you about is a little bit more out there. Do you guys know what I mean when I say comprised? It's like made up of. Okay, so this segment bisector, perpendicular bisector, is comprised of infinitely many points that are all equidistant from P and Q. Okay, let's take a minute to think about that for a second. If I were to draw, do you guys have rulers? If you don't have one, would you get one, please? Okay. So because we had our compass set at the same setting when we did both of these arcs, both of our arcs had the same radius. Do you guys see that this distance right here is the radius of this circle that we didn't complete, right? So this radius is the same as that radius. Everybody see that? Okay. Any point that I pick on this perpendicular bisector is going to be equidistant from P and Q. Okay, so these two are also equal to each other. Any point I pick on that bisector, that perpendicular bisector, is the same distance from P as it is from Q. Everybody okay with that? Okay, so our last one is made up of points. Let's say infinitely many points, guys. Let's say infinitely many. What did I do? Oh, into, goodness gracious, made up of infinitely many points that are equidistant from points P and Q. Okay, that was a lot. Okay, questions about those properties? Okay. What is special about point M? We kind of already said this. M is the what? Midpoint. Yes, M is the midpoint. So a perpendicular bisector intersects the segment at its midpoint. Okay. Whew. Next, we've got a couple of fun little theorems.
Well, I didn't get that. Can you back up?
Yes. All right. You don't have to do a whole lot of writing because it's already written for you, but you do need to know these things, so please listen. Okay, our perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, we kind of already said that, but in a different way. So we have point X here that is on a perpendicular bisector of segment AB. Okay, here's point X. It is equidistant from A and B. Okay, let's look at the ticks really quick. The perpendicular bisector is intersecting AB at its midpoint, so that I know that AY is congruent to AB. Do you see how each of those has one tick? Those are congruent to each other. Now, if I want to say that a second pair of segments is congruent to each other, but not necessarily to the first two, I have to give them a different amount of ticks. You see that? I had to up the ticks to 2. Okay. Everybody okay with that? Because we're going to do the same thing for angles with arcs. Okay. So we know that segment XA is congruent to segment XB. Okay. Therefore, their measures, their lengths are also the same. Okay, now a converse is a logical statement that is like in reverse. So a converse is a logical statement that's in reverse order. Okay, my word is being dumb. Hold on. I'm going to fix it really quick. Okay. Okay. Oh, thank you. So we also know that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So these two things we know are true backwards and forwards. If we have a point on the perpendicular bisector, it is equidistant from the endpoints. Okay? If a point is equidistant from the endpoints, then we know it's on the perpendicular bisector. See how it goes forwards and backwards? Okay, I'm going to say it again. If our point is on a perpendicular bisector, it is equidistant from the endpoints. That's forwards. Okay? If these two lengths are the same, then we know that x is on a perpendicular bisector. It's not as cool as the first one, but it's true. Okay? We'll use that information both ways. All right, let's go to the next page. Okay, we're going to find the measure of TU. So let's look at the information that we have. What do you think is special about WU, the line WU? What can we call this? Okay, look at it. Look at the angle. Does it make a right angle? Okay, is it chopping a segment in half? It's a perpendicular bisector. Okay, so now that we know that, we can say that not only are these two segments congruent, we can say that these two are. Everybody see how we got there? Okay. So if my figures are congruent, then I know that my measures are equal. So by the definition of congruence, I can say that 3x plus 9 has to equal 7x minus 17. And the rest is just a really easy algebra problem. Do we subtract away 3x from both sides? Okay, add 17 to both sides. 9 plus 17, is it 28? Do I need to show those steps or are we good? Promise? Okay. Now what? Yeah, divide both sides by 4. So what's x? 7. Good. So did they ask us to only find x and stop? What did they ask us to find? We have to find the measure of TU. So we are going to plug that back in. So TU is 3x plus 9. We know that x is what? 7. So 3 times 7 plus 9. 27 plus 9. 36. Oh, it's 21. I always do that. Gosh darn it. 7's tables. Okay, 21 plus 9, 30. Okay. So the measure of TU equals 30 units. Okay, questions?
Well, 17 plus 9 is a 28. 26.
What, did I mess up again?
Yeah.
What did I do?
17 plus.
Oh my gosh. All right, let's go back. So this is what I messed up?
Yeah, it's not that bad.
Okay. What is it? It's 26?
Yeah.
I like my answer better. Okay, it's only 26. That is a sad day for math teachers everywhere. Okay, they're going to come from my math middle. So it's not 7. What is it?
6.5.
Jeez Louise. 6.5. All right. Now we got to erase this. Gosh, I had one job. Okay, so 3 times 6.5 is what? Oh, it's going to be gross. Plus 9. $28.5. Oh, I liked it better when we did it wrong. All right, it's fine. I'm going to cry about this later. All right, any other questions now that it's on the board correctly? Okay, there's a whole bunch of math teachers that are going to watch this video too because the other, one of our subs can't come in anymore right now. So they're all going to see my shame. It's going to be great. And it's going on the internet. Awesome.
I'm going to share it to all my friends.
Great day.
Yeah, why can't you just cut it out?
I don't know how. Okay, to add to my shame, I don't know how, nor do I have time. So we're just going to have to live with it. Given that line L is the perpendicular bisector of segment DE, that measure DE is 20.8, that measure of DG is 36.4, and then the measure of EG is 36.4, find the measure of EF. Okay, that was a lot, but it's fine. We have this figure we can label. So let's start putting the stuff that we know on here. This is a perpendicular bisector, so what do we know about DF and FE? They're going to be the same because they got chopped in half and made into 2 congruent baby segments. Okay, point G is on the perpendicular bisector. So what do we know about DG and GE? They are also congruent. Okay, everybody see how we made those leaps? Okay, now we're going to put some numbers on our picture. Okay, DE, the whole thing is 20.8. All right, so each of these little pieces is half of that.
So that's 10.
I agree. Okay, EG is 36.4. And so is this guy. Okay, what is EF? Oh, we already did that. We just labeled it. That was easy. Okay, so we'll just use our notation. Measure of EF equals 10.4 units. Okay, a little bit of a note about notation. Pre-AP is going to use this. Everybody else in the whole world is just going to write this as EF equals 10.4 units.
Why would I choose that?
There's one in front of the door.
Yes.
How would this work?
All right, midpoint. The midpoint, M, of segment AB is the point that bisects. We know that means chops in half. The segment into two congruent segments. If M is the midpoint of AB, then AM is congruent to MB. So let's draw a little picture. Here's my AB. Okay, M is the midpoint. So these two are congruent to each other. Okay, point M is the midpoint of GH. Let's draw a picture. Here's GH. Okay, the measure of GH is 10. M is the midpoint. Now it says draw and code a picture. When it says code, that means the ticks. And if it tells you that the angles are congruent, we'll talk about how to show that the angles are congruent. Or if they tell you that something is perpendicular, you can draw the little box on the angle. Okay, code is when you annotate with the given information. So this is the coding right here. Boop, 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 boop. Okay, that's code. When you say that those are congruent. Okay, so now we need to find the measure of GM and MH. So the measure of segment GM is what? Equal to the measure of MH. What do they both have to be? 5. Okay, we're on a roll. All right. Here is the midpoint formula, which you saw I messed up yesterday. Put the minuses in it. We'll go back. They're both 5. Find the coordinates of the midpoint for PQ if the endpoints are P, -8, 3, and Q, -2, 7. So remember that finding the midpoint is like the average of each of the coordinates. So this is it's like the average, like the mean, right? Where you have to add them all up and divide by how many there are. Remember we did that? Okay, it's the average of the x's. And then this one is the average, the mean of the y's. So I take my two x coordinates and I add them together. So -8 plus -2 and divide by 2. Oh gosh, I keep doing that. What do you get? Okay, because it's -10 divided by 2, right? Okay. And then for the y's, it's my two y coordinates, so 3 plus 7 divided by 2. So positive 5, because 10 divided by 2 is 5. Okay, this is our midpoint. Questions? I mean, you can use the formula if you want, but it's almost easier just to know that you average the x's and you average the y's. You know what I mean? Because that's what you're doing. And you guys already know how to find an average. Okie dokie. Oh, shoot. All right. This is one of those kind of like well duh type postulates, but we do need to talk about it. Remember that a postulate or axiom is a statement that is accepted as true without proof. We're going to be doing some proofs in here, and we need a couple of statements that we can just accept as true without having to prove them. Otherwise, we have no basis for the rest of our proofs. So this is something that everyone just kind of agrees is true without needing to prove it. So this says IFF. IFF is if and only if. That means that this statement is true backwards and forwards. Okay. If and only if a point B is between point A and C, then the measure of segment AB plus the measure of segment BC equals, anyone have a guess? Like if this is 3 and this is 6, what is the whole thing? 9. Yeah, it's the measure of AC. Like, yeah. So is the measure of segment AC. So this whole thing should be 9. Well, duh, right? So, we're going to do a little proof up here, if I can remember all the steps. So here we have a little segment DF. Okay, it's got a point E on it that's chopping it into parts. We don't know that E is a midpoint. They're not telling us that. Okay, they're just saying it's on the segment. Hey, can you join us, please? Okay, all we know is that it's between those two. We have to find the length of DF. So the first thing we need to know is, okay, the measure of DE plus the measure of EF equals what? The measure of what? DF. Good. Okay, and we know that because of the segment addition postulate. I think that I missed a step. I forgot the given. Guys, we have to pop this down one level. I'm sorry. I messed up.
My.
All right. It's been a long time since I did a proof. It's been a whole year since I did this. So I'm just going to finish writing it on here. Okay, so we're just going to copy this down one level. I got so excited to use the postulate that I forgot myself. Okay, so the first thing that we can say in our proof is the given. So we know that point E is between point D and point F. Point E is on the F. That was given. Okay, that wasn't too bad. Yep.
What's a postulate again?
It's a statement that we accept as true without proof. Okay, So now the other things that we are given in the picture is some little things on our diagram. So what do we know that the measure of DE is? Yeah, so we have to write small, guys. Write this one really small. The measure of DE equals 3x minus 1. Okay, what about the measure of EF? Yep. And last but not least, the measure of DF equals 6x. Okay, so the segment addition postulate gives us the relationship between these three measures. And on the picture, we're given expressions that represent those measures. So the next thing we're going to do is make a cute little substitution. So wherever we see the measure of DE,
You forgot O on.
which one?
Yeah.
Oh, on EF. Thank you. Good catch. Wherever we see the measure of DE, we're going to put in this 3x minus 1. Everybody see what we're going to do? We're just going to plug them in. All right, here we go. So 3x plus 1. Oh, that's a minus 1. 3x minus 1 plus, okay, EF is 13 plus 13 equals 3x, 6x. Jeez Louise. Okay, we got that by substitution. So this is our substitution property. Okay. Really quick, how did I know what all of these measures were? Because they gave it to us on the picture, right? So the reason for this is also given. Okay, now we have some combining like terms that we can do. What is negative 1 plus 13? 12. Okay, and then what about if we subtract away 3x from both sides? Yeah. Okay, so doing that, I think we did combining like terms and the subtraction property of equality. Combined like terms and the subtraction property of equality. I kind of ran out of room. Okay, last but not least, how do we get x? Okay, divide both sides by 3 and we get 4 equals x. So that was the division property of equality. Okay, so what did they ask us to find? Okay, so now we can because we know x. So the measure of df is, well, it says it's 6x. What do we know that x is? Okay, so 6 times 4? Yes. Okay, that was a lot. Questions? Okay, let's do one more. I'm not going to forget the givens this time. I have you guys here to remind me. Okay, so read our little baby paragraph. Point D is the midpoint of EF. So before I do anything else, what did they tell us? Yeah. So point D is the midpoint of EF. Okay, that was given to us. What else did they give us in the picture? What about the measure of ED? What is the measure of ED?
4x plus 6.
Okay, 4x plus 6. And the measure of DF?
7x.
Okay. Okay, that was also given.
Don't you put that one on the next one down?
There are certain things in a proof that have to come before other things. Like you have to put on your underoos before you can put on your pants, right? Right?
On the top one, you said the midpoint of.
Okay, hold on. Listen. But do you have to put on your socks before you put on your pants? Okay, so some things the order doesn't matter and some things it does. So if we go back up to the one that you're talking about, look. I'm going to say this like I'm a little rusty and I forgot the givens, okay? So this given statement, we could have put it second. It didn't hurt anything that we put it third, but we could have written it second. Okay, we could have put on the socks and the underoos and then put on the pants. Okay, what we have to do is we can't use the segment addition postulate until we say that point E is on DF. And we can't use the substitution property until we've used the segment addition postulate. So some things have to come first, but the givens can be, we have a little bit more flexibility about when we write the givens. Does that answer your question? Okay. Okay. All right. So the next thing that we need to know is what? Oh, what do we know about these two measures? What do they have to add? Oh no. Okay, what do they both have to equal? Hold on. If it's the midpoint, what do we know about these two baby segments? Yeah, they're congruent. Let's mark them. Let's code the picture. Okay, so we know that the measure of ED is equal to the measure of DF because of the definition of midpoint. Okay, so to go back to the question about the order, this one I could have put it second, but it has to come after I tell you that D is the midpoint. I can't use the definition of midpoint until after I told you that something is a midpoint. Does that make sense? Like they build on each other. Okay. All right, now that I have those, I can make a substitution. What substitution can I make? What can I put in for the measure of ED?
4x plus 6.
Correct. 4x plus 6 equals 7x minus 9. Okay, that is our substitution property. Okay, now what? Okay, do I have any like terms over here?
No.
Any over here? Okay, so I'm going to have to use my addition and subtraction properties of equality. So how do I get all the x's over onto the right-hand side? Okay, so that gives me 6 equals 3x minus 9. So that was the subtraction property of equality. It's usually about this time where someone asks me, do we have to write these out? And I get to say, if you want the points, yes. If you don't want the points, then feel free to not write them out. Okay, how do we get rid of a negative 9? Add 9 to both sides. You guys better help me with this. My adding has been bad today. 15 equals 3x. That was our addition property of equality. Okay, last one. We're almost there. Home free. What's x? Yeah. So that was our division property of equality. Okay, so now we have something to plug in. So first we want to find ED. So ED, the expression for ED is 4x plus 6, and we know that x is 5. So 4 times 5 is 20 plus 6 is 26 units. All right, let's do DF. Well, they're supposed to be congruent. We should get the same thing. This is a good place to check your work. Sometimes kids just assume that they did it right and write the same thing on the line, but it's really best to make sure that you plug it into both of them. Plug it into both of them and make sure you get the same thing. So let's try it. So 7x minus 9. So 7 times 5 is 35. Take away 9. 26. Whoops. Yay, we did it. All right, now EF should be the sum of those because of the segment addition postulate. 52. Good. Is that the end?
Yeah.
Okay, you survived. Congratulations.